Welcome to MOVITRAC LTE-B Plus Basic and Intermediate Training. This is Session 6. In our last session, we explored Terminal Control Mode, an alternative way of controlling the MOVITRAC LTE-B Plus. We didn't really finish that topic because there's much more to cover, so in this session we're going to continue exploring Terminal Control Mode, and we're going to learn some additional things that you can do with it. We're going to start by taking a look at what's called push-button control. This is something that may be useful for certain applications, so let's talk about how it works. First of all, a few big ideas. Push buttons are momentary switches. In other words, you press them and they change state, but when you release them, they go back to their original state. They generate what are called edges when they're pressed. An edge is basically a transition between two levels, in other words, between 0 and 1 or 1 and 0. Push buttons come in two types. A normally open or NO push button is open when you're not pressing it, and it goes high or closed when you do press it. It generates a rising edge followed by a falling edge. This is the schematic symbol for a normally open push button. You can see that the symbol shows that it's open when you're not touching it, and the second diagram there shows what it does when you press it. Normally it's low when you're not pressing it, but when you press it, it rises to a high state briefly, and then when you release it, it goes back low. It has two edges. The arrows show the direction of the edge. A rising edge is going from low to high, and a falling edge is going from high to low. So a normally open push button does a rising edge followed by a falling edge. A normally closed push button is closed when not pressed, and it opens when you do press it. It generates a falling edge followed by a rising edge. Here's its schematic symbol. You can see it's closed when you're not touching it, and you can see the edges are just the opposite that you would find with a normally open push button. When you're operating in push button control mode, the VFD isn't interested in the on-off condition. In other words, the levels of the signal. It's looking for the edges. The VFD will respond to one of those two edges, either the rising or falling one. All right, with that said, let's see how you can control the VFD with push buttons. There are actually two different variants of push button control. The one we're going to look at first is called start-stop control. It uses a pair of push buttons to start and stop the VFD, sort of like this, and they would be wired in this way. You would connect the start button, which is a normally open push button, to 24 volts on one side and digital input 1 on the other. The stop button is a normally closed push button, and it is wired to 24 volts and digital input 2. This is how it operates. To start the VFD, you press the start button, which is normally low. It goes high briefly. The VFD detects the rising edge and starts operating. Notice as soon as you release it, it goes back to the low condition, but the VFD keeps running. It's only interested in the edge, not the level. To stop the VFD, you press the stop button, which is normally high. When you press it, it will go low briefly, generating a falling edge, and that's what the VFD is looking for. When it sees the falling edge, it will stop, even though the stop signal goes back high as soon as you release the button. So it's a little different from the way we've been controlling the VFD, but I think you can see it makes good sense. Incidentally, maybe you're wondering why we use a normally open button for start and a normally closed for stop. The reason is that this arrangement helps prevent inappropriate behavior if something fails. If the 24-volt supply fails or a wire gets cut, the stop signal will open, and that will cause the VFD to stop, which is probably a safe thing to do. Similarly, the on state isn't going to be triggered by something being cut or broken, so it's generally a bit safer. So this is a typical control scheme for push-button control on a VFD. So if you want to use this particular variant, you pick the start-stop variant. Let's talk about how it works. It is variant number 10. Digital input 1 is wired up to the push-to-start button, which is supposed to be normally open. Digital input 2 is wired up to the normally closed stop push button. Digital input 3, analog input 2, is wired up to an ordinary switch. It selects between a potentiometer for speed control if you put a 0 in, and 1 for preset speed number 1. And then analog input 1, digital input 4 is a potentiometer, so it's functioning as an analog input for speed control. So if the start button is released and the stop button is pushed, it will bring the VFD to a normal stop using the ramp in parameter 04. If you press the start button and the stop button is released and digital input 3 is off, you'll run with potentiometer control. If you push the start button with the stop button released and digital input 3 is on, you'll run at preset speed number 1, which comes from parameter 20. So pretty simple. This is similar to many of the other terminal control modes, with the main difference that push buttons are controlling it rather than simple on-off switches. All right, now there is a second push button control. It is called forward stop reverse control. This variant uses 3 push buttons to control the VFD's operation and direction. Sort of like this. You have a start forward and a start reverse button and a single stop button. You would wire them up this way. The 2 start buttons, forward and reverse, are normally open push buttons. They're connected to 24 volts and also connected to digital inputs 1 and 3. The stop button is a normally closed push button. It is also wired to 24 volts and digital input 2. So control works something like this. To make the drive run forward, you press the forward button, which goes from low to high briefly. The VFD sees that rising edge and starts up in the clockwise direction. To stop the VFD, you press the stop push button, which is normally high. It briefly goes low. The VFD detects the falling edge and stops the motor. And to reverse, you press the reverse push button, which is also normally low, but when you push it, it goes high. The VFD detects that rising edge and starts in the counterclockwise direction. So this is really just a variation on a theme. It is similar to start-stop control, but you have 2 directions instead of 1. Let's look at the variant that implements this one. It is variant 11. Digital input 1 is connected up to the start clockwise push button, which is normally open. So you push it to start the VFD moving clockwise. Digital input 2 is connected to a normally closed stop push button. If you push it, it will stop the VFD. And digital input 3, analog input 2, is connected to the start counterclockwise push button, which is also normally open. You push it to start the drive in the counterclockwise direction. Analog input 1, digital input 4 is operating in analog mode here. It's connected up to a speed control potentiometer, so there is only potentiometer control with this variant. So if you release the first and third push buttons and push the middle one, you will get a normal stop using the ramp in parameter 4. If you press the first push button and leave the other 2 alone, you will run the drive clockwise with potentiometer speed control. If you push the last button and don't touch the other 2, you will run counterclockwise with potentiometer control. And there's an extra little feature here. If you push both start buttons at the same time, you will get a rapid stop using the ramp in parameter 24. Kind of interesting and very useful. I think it's time for a hands-on here so you can play with these 2 and see how they work. So here's what I'd like you to do. I'd like you to change to terminal control mode variant number 10. Then test the drive to confirm its operation with the potentiometer and at the preset speed. Once you're happy with that, change to terminal control mode variant number 11 and test the drive to confirm operation in both directions and with both stops, both normal and rapid. Let me give you a tip. If you're thinking, wait a minute, I don't have push buttons on my demo unit, that's okay. You can use regular switches to simulate them. What you need to do is you set the switch to the push button's normal state. So if the normal state is normally open, then turn the switch off. If it's normally closed, turn it on. And to simulate a push, flip the switch to the opposite position briefly and then flip it back. And that simulates a push button. So you can do that with ordinary toggle switches. Go ahead, pause the video, and do the hands-on. All right, well, I hope that worked for you. I'm now going to demonstrate how to do it, so if you had any problems, this should clear things up, and if you don't have a demo unit, you can see what it would be like if you had tried it out. Let's demonstrate this. Okay, well, we're in LT shell, ready to make a few changes to our parameters. We're exactly where we were at the end of session 5, so almost everything is already appropriate, but we do need to make one change. First thing I need to do is change to real-time edit mode, so I'm going to affect my parameters as soon as I change them. And I'm going to change to the extended parameter tab here. I'm going to pull down parameter 15 and pick 10, which is my first push button control variant. All right, I don't need to change anything else. I'm just going to point out a few things here though. Notice our presets are still set the way they were in session 5. Preset 1 is 100 RPM. We'll be using that one when we test this. Notice also our fast deceleration ramp is 1 second. And if I go back to the basic parameters, my standard deceleration ramp is 4. All right, so we've made all the changes we have to make to test things out. I'm going to turn off real-time edit mode, and I'm going to go over to my VFD, and I'm going to push a few buttons and see what happens. Okay, the first thing I need to do is put the stop switch to its normally closed condition, so I'm going to turn that on. And now I'm going to start the drive by pulsing digital input 1, and I have to turn the potentiometer up to bring it up to speed. There we go. Now I'm going to stop the drive by pulsing the switch off and back on. You can see it stopped the drive. I can restart it. I can switch to the preset speed, which is 100 RPM. I can stop it, I can restart it, and I can stop it. All right, well, we can see that that worked just fine. So now we're going to try the other push button variant. So we need to go back to the extended tab, re-enable real-time edit mode, and I'm going to change parameter 15 to 11, which is our second control variant that involves push buttons. That's all I have to do here. I'll turn off real-time edit mode and let's go push a few buttons. All right, first thing we have to do is turn the stop switch to the normally closed position, and we'll try pressing the start forward button and turn the pot up to make the motor turn. That works. Now we'll stop it by pulsing the stop button and pulse the reverse start button. That works too. Stop it. Pulse the start button in the forward direction again, works fine, stop it. Now let's go to maximum speed. We're going to play with the 2 stops. Get it going, maximum speed. Now watch how long it takes to decelerate. Fairly long time because we have a long ramp programmed here. Now let's restart it. We're going to do the rapid stop by turning forward and reverse on at the same time. That invokes a rapid stop, and you can see that's a lot quicker. All right, well, let's move in a slightly different direction. We're going to look at a feature that's available for some variants in terminal control mode, the ability to monitor an external sensor, and when the sensor activates, trigger a VFD fault. So what's this all about? Well, there are many applications where it's important to be able to shut down the VFD if something goes wrong. These applications include sensors that can detect problems, such as a jam or maybe an over-temperature situation. Whatever the sensor is, when something goes wrong, the sensor activates, it triggers a fault in the VFD, causing it to stop the motor. The MOVITRAC LTE-B Plus has the capability of monitoring a single external sensor. Several variants in terminal control mode include the ability to do this. We're going to look at those, but let's talk about sensors for a second. Fault sensors are usually what we call active low. What that means is when everything is normal, they're outputting a high value, in other words, 24 volts, but when something goes wrong, the output of the sensor goes low. It comes down to ground level. You may wonder, why does it work this way? It's kind of a safety feature. The idea is if something goes wrong with the sensor, such as its wire gets cut or its power supply fails, you want it to trip the VFD into a fault condition, causing it to stop the motor. That's generally considered safer than allowing it to just keep running. So almost all fault sensors tend to be active low, and that is certainly what the MOVITRAC LTE-B Plus expects on the input that monitors the sensor. There are 3 terminal control mode variants that include the ability to monitor an external sensor. We'll talk about those in just a minute. Another common use of this type of monitoring is motor temperature monitoring. As you probably know, many motors include either a thermostat or a thermistor sensor in the windings to check for over temperature conditions. If the windings get too hot, the sensor triggers and the VFD shuts down the motor to protect it from thermal damage. The MOVITRAC LTE-B Plus can also monitor these kinds of sensors. We'll go over how to configure the MOVITRAC LTE-B Plus to be able to handle either a generic external sensor or a motor temperature sensor. Let's start with a generic external sensor. How do you wire it up to the VFD? Well, you make connections on the front I/O connector, as you do with all devices connected to it. This is how you would wire it up. You would connect an active low sensor to digital input 3, analog input 2. Now, as I mentioned in an earlier session, you generally should not supply power to devices using the built-in power supplies on the MOVITRAC LTE-B Plus. The reason is it doesn't really have enough current to support anything but very small devices. So in most cases, you're going to use an external power supply to power the sensor, but you do need to connect the power supply's ground to one of the 0-volt terminals on the MOVITRAC LTE-B Plus. This simply brings everything to a common ground reference so that it's able to monitor the sensor correctly. So this is the proper way to wire it up. Now, how do we configure the VFD to monitor the sensor? We simply have to pick the correct variant of terminal control mode. We go into parameter 12 in the basic parameters to activate terminal control mode and parameter 15 in the extended parameters to select a variant that supports external sensor monitoring. So parameter 12 should be set to 0. That selects terminal control mode. We looked at that in our last session. And then parameter 15 should be set to 3, 6, or 7. These are the 3 variants that support monitoring external sensors. So pick the one that has the combination of inputs that you wish to use, and you're pretty much all set to go. Now, what happens when a fault occurs when that sensor goes low? Well, you'll see something like this on your VFD. The sensor will go low and the display will change to E trip and the motor will stop. And this indicates you're in an external sensor trip condition. When this occurs, you will not be able to run the motor until you clear the fault. So how do you do that? It's pretty simple. First, of course, you have to eliminate the cause, whatever caused the sensor to go low. So the sensor needs to return to the high condition. And then you clear the fault from the VFD either by pressing the stop button on the keypad or by providing a rising edge on digital input 1. If you have a switch connected to it, the way to do that is to turn it off and then back on. That will clear the fault and the VFD will be ready to run again. So that is pretty much how you handle external faults. Now let's pause for a second. I want to give you a warning. The VFD may actually restart the motor immediately after you clear the fault. It depends what it was doing when it faulted and what state the controls are in. Therefore, you should always be absolutely sure you've taken suitable precautions before clearing faults, that you've considered the possibility that the motor may restart. If you don't want that to happen, be sure you've removed the enable on the VFD or done something else to immobilize the drive. Okay, you have been warned. Let's continue. Now, what if you want to connect up a motor temperature sensor, either TH, which is a thermostat, or TF, which is a thermistor? Do you have to do anything special? And the answer is only if you have a MOVITRAC LTE-B Plus. The MOVITRAC LTE-B Plus has a dedicated parameter and error message associated with motor temperature monitoring. It's parameter 47 in the extended parameters, so you need to go in there and you need to set it to PTC-TH. And that will tell the MOVITRAC LTE-B Plus that it's monitoring a temperature sensor and not some other kind of device connected to its analog input. Now, if you have a MOVITRAC LTE-B, the earlier version, there is no parameter 47. You don't have to set anything if you're monitoring a temperature sensor. The difference is the MOVITRAC LTE-B treats temperature sensors simply as generic fault sensors. You won't get a specific error message indicating it was an over temperature condition. You'll simply get the standard E-trip message. So that's really the difference. The MOVITRAC LTE-B Plus added this little feature to make it a little more intuitive as to what's going on. So you'll set that parameter and then you'll make the connection to the temperature sensor in this way. You'll wire it between the 24-volt supply and the MOVITRAC LTE-B or B+, and you'll connect the other end to digital input 3, analog input 2. You are allowed to use the built-in power supply for monitoring motor temperature sensors because they don't draw much current. Do note that the sensor must have a 2.5 k ohm threshold for tripping in order to be detected correctly. Once you have it wired up and running, everything should be fine unless the motor overheats, at which point you will get a fault. Now what you get depends on the VFD that you have. If you have a MOVITRAC LTE-B, you'll get the generic E-trip message. If you have a MOVITRAC LTE-B+, you'll get a special message that will say F-PTC. That means you have a fault caused by the temperature sensor. So the message is a little more specific, but both messages essentially mean the same thing. The temperature sensor is tripped. Of course, you clear it in exactly the same way. You let the motor cool down and you correct the problem. Then you clear the fault by pressing the stop button or providing a rising edge on digital input 1. Let's do a demonstration. I'm going to show you how to set up a generic sensor on the MOVITRAC LTE-B+, and then I'll switch to a temperature sensor and I will show you how both of them behave. You'll see they're practically the same thing. Well, let's demonstrate using an external fault sensor. In order to do this, we need to change to a variant that supports an external trip detection. I'm going to turn real-time edit mode on, and I'm going to go to parameter 15, and I'm going to pick one of the variants that includes a trip run signal. Let's just pick variant 3 here. You can see the first signal is stop run, then there's a selection between the potentiometer and preset 1. The third input is trip run, and the fourth is the potentiometer. So that one's good for this application. I'll pick this, and that's the only thing I have to change. So now let's demonstrate it by running the motor, and then we're going to trip the sensor and see what happens. All right, I'm going to turn the switch connected to digital input 3 on to simulate a normal sensor condition, and I'm going to start the drive, running at a preset speed. Now let's trip a fault. We're going to turn DI3 off. We get E-trip. Now I turn it back on again to clear the sensor condition, and I press stop to restart the drive. You notice it restarts immediately without warning. Let's trip it again, and now clear it by turning DI1 off and then on. Again, notice it restarts immediately, so always be careful when you clear a fault because the drive could just take off without warning, and that could be disastrous. So think twice before you do that. Well, we can see that that worked okay. That's what you'll experience if you connect just any generic active low sensor to digital input 3 and put it in one of these variants. Now let's look at what you would experience on a MOVITRAC LTE-B+ with a temperature sensor. Of course, on an LTE-B, you're just going to get exactly the same thing, a generic E-trip signal, but the LTE-B+, which is what I have here, has a special mode that's appropriate for temperature sensors. I'm going to leave parameter 15 set to the same variant. That'll work just fine, but we do need to make one additional change. We need to go to parameter 47, and we need to change that to PTC-TH motor thermistor input. So we're going to change that, and now we're going to run our VFD, and we're going to simulate a temperature sensor trip by flipping the switch. Let's try that out. Okay, same situation here. I have the switch connected to DI3 turned on to simulate a temperature sensor that is happy. I'm going to start the drive at a preset speed, and now I'm going to trip DI3 off to simulate a temperature fault, and you can see we get FPTC. I'll turn the switch on again to simulate cooling off, and I'll restart the drive. I'll trip it again, and I'll restart it by turning DI1 off and then on. Exactly the same behaviors with a conventional external sensor, but a dedicated error message. All right, now let's move on to another topic associated with terminal control mode, and that is terminal control in keypad mode. You may not be aware of this, but when you're in keypad control mode, in other words, parameter 12 is set to either 1 or 2, the VFD actually does monitor its inputs, and it is controllable by the inputs. So keypad mode really includes a kind of restricted terminal control mode. You don't have as much functionality as you have in dedicated terminal control mode. That is the mode when parameter 12 is set to 0. but you do have some control using the inputs, and you can take advantage of these. Now, what the inputs do depends on the variant you select. You use the same parameter that you use in terminal control mode to select the variant, parameter 15. But as I said, there are fewer choices available. Also, there is one very definite difference. Digital input 1 always functions as the enable signal. As you recall from an earlier session when we operated in keypad control mode, you had to turn on digital input 1 either with a switch or by jumpering it to 24 volts. So the inputs behave a little bit differently. I'll show you the most common, and actually this one applies to variants 0, 5, 8, 9, 10, 11, and 12. That's half the available variants. So, of course, digital input 1 is the enable signal. If it's 0, the VFD will not be able to run. If it's set to 1, it will. Digital input 2 is a push button to increase the speed. So every time you push it, the speed will increase. So it should be a normally open push button connected to it. Digital input 3, analog input 2, is a speed decrease button. Again, it should be a normally open push button. Every time you push it, it will decrease the speed. So these two buttons function a lot like the up and down arrows on the keypad. And then finally, analog input 1, digital input 4 is connected to a digital switch, so the input functions as a digital input here. It controls direction. If it's 0, you'll get clockwise rotation, and if it's 1, you'll get counterclockwise rotation. So fairly straightforward. Essentially, what you're getting here is a terminal version of what the keypad does. Remember, you can operate the keypad to do all these things as well. So perhaps you could use this for sort of a remote keypad using some push buttons and a switch. There is one extra little feature I will mention. If you press both speed control buttons at the same time, the drive will start. So that is an interesting little extra. Let's demonstrate this. I'm going to go to my MOVITRAC and show you how this works. We're going to see how terminal control mode interacts with the keypad when we're in keypad control mode. Now, the first thing we need to do is change a few things so that we can operate in keypad mode. I'll turn real-time edit on. I'm going to disable the temperature sensor monitoring that we set up last time by changing parameter 47 back to 0. And then I'm going to go back up here to the top and change parameter 15 to variant 0. And then finally, I'm going to go back to the basic tab and change back to keypad mode by changing parameter 12 to 2. That's keypad mode bipolar. Now I will be able to control my VFD using the keypad in the usual way, but I'll also have that limited terminal control mode. Let's go demonstrate that. All right, the first thing I do is enable the drive by turning DI1 on, and I press the start button on the keypad, and I'm going to just speed it up the conventional way you do with the keypad with the up arrow. We've done this before. And I'll slow it down with the down arrow. This is familiar ground. But now I'm going to switch to using the push buttons. So I'm going to turn DI2 on, and as long as you hold the push button down, the drive will speed up till it hits maximum. I'll pulse this one to simulate pressing the button for a brief time, and you can see that slows down in little bursts. I'll go down a ways. And now I'm going to use the potentiometer, which is behaving like a switch here, to reverse direction. If I turn it all the way up, it reverses. If I turn it all the way down, it goes forward. So it's acting digitally here. Let me slow the drive down to a stop. I'm going to stop it from the keypad. Now watch this. If I turn DI2 and 3 on simultaneously, it starts the drive, just like the start button. Then I can speed it up. Or slow it down. Or bring it all the way to a stop. All right, one final thing, and then we will be done at long last with terminal control. We're going to talk about how to get bidirectional speed control using the potentiometer. Now, you may be wondering what this is about. Well, let me remind you of something we talked about in our previous session when I introduced a number of the variants available in terminal control mode, we looked at variant 1, and I mentioned that in this mode you didn't have a signal that controlled the motor's rotation direction. And I said that when you're operating in this mode, the way you control rotation direction when you're operating with preset speeds is by setting the sign of the preset speed. A positive preset rotates clockwise and a negative rotates counterclockwise. And I mentioned at that time that when you're operating in potentiometer control, you were stuck with clockwise rotation. Well, that was certainly true. However, you can change that. And I deferred talking about it until this session when it will make more sense. So I'm going to show you how you can modify the VFD by changing several parameters so the potentiometer can control both direction and speed at the same time. Here's how you do that. To set up bidirectional control with the potentiometer, you need to go to parameters 16, 35, and 39 in the extended parameters. And this configures the behavior of the potentiometer. So the first thing you do is go to parameter 16 and change it to B 0 through 10. What this means is you're going to get bidirectional control when you supply a 0 to 10 volt analog signal on analog input 1. So change it to this, and that will allow you to get bidirectional control. Then you need to go to parameter 35, which controls analog input scaling, and change it to 200%. By default, it's 100%. What you're essentially doing is doubling its range because you're going to be controlling it in two directions, so you have to double the range. And then finally, you go to parameter 39, analog input offset, and change it to 50%. What this does is it shifts the control range to the center of the potentiometer instead of one end. Essentially, this is what happens. 0% is in the middle of the potentiometer's rotation range, and then you have plus and minus 100% with the counterclockwise and clockwise directions of rotation. What will happen when you fire up your VFD, if the potentiometer is set near the middle, the VFD will be stopped or turning only very slowly. When you turn the potentiometer clockwise, the VFD will also rotate clockwise. It will range in speed from 0 to 100% of its maximum speed. And when you rotate it counterclockwise, the VFD will also rotate counterclockwise at a speed between 0 and 100% of the maximum speed. Let me demonstrate how to do this, and I'll show it to you using my demo unit. All right, to operate in bidirectional potentiometer control, what I need to do is change back to terminal control mode. So I'm going to go into real-time edit mode. Then I'm going to change parameter 12 back to 0, terminal control mode. And then go to the extended parameters. And I'm going to pick a variant that doesn't have direction control. Variant 1 is good for that. Now I need to configure my potentiometer. The first thing I do is go to parameter 16 and I change it from 0 to 10 volt to bidirectional 0 to 10 volt. And that's going to enable the potentiometer to do bidirectional control. Then I need to change analog input scaling parameter 35 from 100% to 200%. And then finally, I have to change the analog input offset to 50%. And that is all I need to do to configure my VFD to use the potentiometer as a bidirectional control. So I'll turn off real-time edit and I will head over to my VFD and let's give this a try. All right, I'm going to put the potentiometer in the middle so the drive shouldn't be moving too much, and I'm going to enable it. And you can see there it's just barely turning at about 94 RPM. I turn it clockwise, the drive goes clockwise all the way up to its maximum. If I turn it counterclockwise, it'll bring it to almost a stop when we're near the middle, and then it will go counterclockwise if I keep turning it all the way up to the negative maximum. And if I move it back to the middle, it should come to almost a stop, and now let's switch it off. And we are finally done with terminal control mode. I'm sure you're rather tired of it by now, but as you can see, it's a very versatile mode with a lot of capabilities. In our next session, we're going to look at several miscellaneous topics. We'll discuss faults in greater detail and how to find out more about them when they occur. We'll also talk about a number of parameters that enable various useful features in the MOVITRAC LTE-B+. See you then.